Section 6, we're talking about trapezoids and kites. The first one we're going to talk about specifically is trapezoids. It is a quadrilateral with exactly one pair of parallel sides. Okay, those parallel sides are called the bases, and the non-parallel sides are called the legs. Okay, so these guys, AB and CD, those are our bases. And then AD and CB are our legs. Okay? If a quadrilateral is a trapezoid, then its consecutive base angles are supplementary. Okay, remember supplementary means that their sum is 180 degrees. This consecutive base angles, these are not on the same base. All right, so A and D are supplementary. Same thing with B and C. They are consecutive base angles. They are supplementary. Okay? The midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs. All right? Now our midsegment, it is parallel to each base. It's like kind of like cutting the trapezoid in half. If you were to fold from base to base, that midsegment's going to cut that trapezoid in half. Okay, and that fold, that midsegment is parallel to each base, and its measure is half the sum of the bases. So if this base here is length A, this length here is base B, we'll let our midsegment be M. The length of our midsegment is half the sum. A plus B divided by 2. Okay? Now, just like there were special parallelograms, there are special trapezoids. And an isosceles trapezoid, that word isosceles should ring a bell. Isosceles triangles have two congruent sides, and those two sides are called that are congruent are called the legs. So an isosceles trapezoid is a trapezoid whose legs are congruent. Okay, now it's still a trapezoid, so those consecutive base angles are still supplementary, and that mid segment still holds true. The length of it is half the sum of the legs, or of the bases, excuse me. My apologies. This is bases up here. Okay, but an isosceles trapezoid, each pair of base angles is congruent. Okay, so up here, A and B, that is one pair of base angles. They are congruent. And then C and D, that's one pair of base angles. These guys are on the same base. They are congruent. Okay. And an isosceles trapezoid, its diagonals are also congruent. So AD is congruent to BC.